Hello again. So I thought I would make another video on exploring this Horizon um, library or service and how we can think in terms of Elm architecture and all that stuff combined with Horizon and also using rxjs observables. So we had like Horizon, a great service. We have inspiration from the Elm architecture. And we also have observables. And this is just an experiment. I'm just exploring stuff. And I thought I would just show you what I've been doing here. So this is just a simple chat application. It's an homage to IRC or MIRC, which was an IRC client, which I used when I was like 14 years old or something. So what we can do here is that I can say join some channel and I can do some chatting here. Hi, hello, and I get the message there. Now the thing is, if I go into Firefox and I join the same channel, we can see that I get the text hi, hello. So it kind of like it picks up the messages 5 minutes ago, and then of course if I write something here, foo, and I go back to Chrome, then it says foo, bar, and yeah. So I thought we could take a look at how this has been architected and how the code looks using Horizon. So first let's look at like the architecture here. What's this? Try the new presenter view. Oh, okay. So the idea here is that if you're familiar with kind of like Redux or Elm for that matter, it's based on firing off some kind of action. And this action has a type and it can have a payload. So up on the left here, we have an action being dispatched into the application and it has some type. And the payload is foobar. So on the first step, it will send this action into all the registered reducers of the application. And each reducer handles a scope of the state tree where it can change that state and return it to the complete state tree of the application. And then it moves to the next reducer, passes in the scoped state for that reducer, lets it handle the action if it wants to, and then passes some new state back to the complete state tree. And so it moves to the next reducer, does the same thing, moves back. In Elm, you would actually return not only state, but you could also return effects. In this architecture, you don't do that. Instead, it takes the action, runs it through the reducers, and then it actually attaches the current state of the application, all the state, to the action. And the reason for that is that very often you need access to the current state of the application when you do side effects. So again, it runs through all the reducers, which updates the state, and then it attaches the state, and then different effects can pick up on actions. So kind of like effects register to actions. And if there's a match, in this case, some type, it's a match, it will pass that action into the effect, where it has access to the payload of the action and also all the state of the application. And then that effect will produce a new action, which is passed in on the top here, which will go through all the reducers, and maybe it produces a new effect. So for example, if some type here went through the system here, maybe reducer 1 picked up on some type and changed the state. But reducer 2 and reducer 3 didn't do anything. Then it came down to this point where it attached the state, and effect 1 picked up on this action. And then effect 1 returned other type action, maybe giving it some payload. And then it will go through the system again, and maybe there were some state changes, and then it would be picked up by effect 2, which would then go through the system again. Whenever an action reaches the bottom here, an update, then that will trigger a state change, which you can subscribe to. So this is just playing around with architectures and how we can combine effects and reducers and all that stuff, and get access to the state where you want to get access to it. But yeah, I hope that made some sense. So let's move into the code there, or maybe we can refresh here, and let's bring up the console. So what we can see here is that there's some logging going on inside this architecture. So first of all, we can see that it triggers an action called connect horizon, and which is passed into some reducers, but it doesn't actually do any state change. And as we can see here on the object, this is the 3 reducers I have: horizon, messages, and user. But it didn't make a change. But what it did was trigger an effect. So as we can see here, that an effect was triggered, and a new action was put into the system called horizon status ready, and it was returned from the effect called connect horizon. And this actually made a state change. As we can see, it made a change inside the horizon, and what it did was change is connected to true. It doesn't log the exact property it changed. It could do that, but I haven't implemented it. And then we see that this action also triggered an effect. So it goes through the loop again. And now we got a new action into the system called loaded user. And it was returned from the effect get user. And this makes a change on the user, and yeah. And if I update some code there, we can see that update message, and I can join the test channel, write something. I can join another channel, whoop, and I can change between these channels, and I can close one channel. And this is actually kind of complex because you only want to watch messages on the channels you actually have activated. And when you close a channel, you don't want to watch that channel anymore. So this is actually quite complex to handle this. But let's move into the code and see what it actually looks like. So my main file here imports this small library thingy, which is the implementation of the architecture I explained earlier. And then we have an application, and we bring in the 3 reducers, and let's take a quick look at them. For example, horizon. It has some initial state, and actually this shouldn't have a user. Let's remove that. Yeah, I've been refactoring and trying things out, so there might be some old code here. But anyways, what this does is pick up on actions that states horizon status ready, or there's an error. Then it changes the state and returns it. It doesn't do anything special. It's just a normal reducer. Yes. And if we go back to the main file, we have quite a bit of effects here. For example, we watch messages, we connect to horizon, we store messages, we store the user, because every time you open or close a channel, we want to store that on the user. So when you refresh, you join the same channels again. And then we have the initialization of the application. And what it basically does is pass in some reducers, and it passes in the effects. So that's basically all you do. You create the application, passing in the reducers and the effects, and what it returns is a stream of state changes. And that state stream we just subscribe to, and then we call the render app function, which is a React application where we pass in the state. So whenever there's a state change, we just re-render the whole application. And we could make this better. We could optimize it. We could put the state on the context of React, and maybe create some higher order components or a decorator for extracting the state the component actually needs, and do shallow checking on it to optimize its rendering and stuff like that, but not for this demo. And when we subscribe to state, after that we dispatch connect horizon. Okay, and that fires up the application. So the reducers aren't really the interesting thing here, but let's look at the effects. So as I said in the architecture here, whenever there's an action triggered, any effect can hook onto that action and trigger some side effect. So let's look at how that's done. So connect horizon hooks onto the connect horizon action, which was triggered in the main file here at the bottom here. Okay, and the way it does that is using a function called action effect, which is also from the implemented architecture. And basically what it does is hook onto the action stream into the library, and it filters out this specific action so that you can and you get an observable which you can map and do all crazy things on. And what we want to do here is basically just trigger the horizon connect method, and that doesn't do anything special. Like it's just a side effect. It just triggers horizon, and then we just delay 500 milliseconds because it's so fast locally that you wouldn't see the logo. So it's just to make the experience a bit better. So you see the initial logo with the loading indication, and then it opens up the application. And then we do something interesting. Now we use flat map. So flat map, think of it as, well, let's talk about this first. Horizon.status returns an observable of observables. And that means that whenever the status of horizon changes, this thing here will fire up a new event or a new value, which will be passed into this map here. So if horizon.status just return one observable, like one value, we would use map. But since we are subscribing to multiple values here, we need to use flat map. And what's kind of cool is that I can just express this. I can just say that, okay, we want to listen to the status, and whenever something happens to the status, we want this code to run, which it does. So based on the different kinds of status types, we produce a new action which will go through the system. So imagine here that we have our what do I call, connect horizon here, which is picked up by connect horizon, and whenever, and this side effect kind of like keeps going, so it's kind of like a task really, or a process, and this keeps running, and whenever there's a change in the status of horizon, it will return a new action that will be put into the system so that the reducers and other effects can react to that. Okay, I hope I'm not over-explaining things here. I just want to make it clear. Okay, so that's the connect horizon. Get user is a bit more simple. It just hooks on the horizon status ready action, and it returns the current user. And you might say that why use flat map here? We are just returning one user. And I suppose it's because the fetch method in Horizon just returns an observable of observables, even though you only have one user. Even like if you want to store something in Horizon, you can store multiple things, which means that you will get multiple values back as well. So I suppose it's the same thing with fetch. But when we get the user, we trigger a new action and put the user on as a payload to that action. So this is a very typical thing. You fetch something, you trigger a new action, or you create another action if something fails. Okay, but let's jump into the watch messages, because this is where it starts to get really interesting. As I said, it's kind of complex, joining channels, leaving channels, listening for the correct messages, and all that stuff. So let's go through this. let's just ignore these two up here for now. But what I'm doing is whenever there's a change in the channels, which happens when we load the user, because then we get the initial channels, or we join a channel, or we leave a channel, we want to update our channels. So we use a scan method for this, and this is like a reducer. So what we do is pass in an array, which is like no channels. And if the action type is loading a user, we will get the channels from the user, or if there are no channels, we have an empty array. And then we return that, so that we kind of like build up the channels here. Now the thing is that I pass in the name, and I also pass in from when do I want to bring in messages. So, and that's from now. I don't want to bring in messages from like from several days ago. That will be a lot of data. So I want basically only from now. But as I said, I will show you later. I actually changed that to 5 minutes ago when I actually query the messages, because I want the messages 5 minutes ago and into the future. Anyways, so loading the user, we get the channels from the user. If we join a channel, we update this array inside the reducer with the channel we joined. And if we leave a channel, we remove that channel from this array. So this scan here will keep a list of all the channels. Okay, and whenever this array changes, we map over it. And the way we map over it is that we create, let's look at this first. We want to hook onto the messages collection. We want to grab the messages from 5 minutes ago and into the future. And we want to order them on date time. And then we find all messages related to this specific channel we are now iterating over. Or we are iterating over the channels and now looking at the specific channel. And then we watch it. And then whenever we get an update, and we will get all the messages actually, we map over them to indicate which channel we actually grab messages from, because we need to know that in the UI to put the correct messages in the correct channel. And then we actually want to stop watching these messages at some time, at some point, and that is when we leave a channel. And that is when we use this take until. So we will watch this messages collection until we reset it. And this is where these two things up here are very handy to have. What we do is we react to two different effects or two different actions, leave channel and join channel. And these are just two streams. And what we do is whenever we leave a channel or we join a channel, we will actually stop all the current watched collections. Okay, so we might have 3 channels, and whenever we leave or join a new channel, we will stop watching all of them. And the reason for that is that we need to, we want everything to run through this observable here. So if we didn't reset all of them, we would update, for example, with a new channel, and we will get in here and we would return a new set of watchers for all the channels again, which would mean that we would listen twice on one channel. So instead of managing that, whenever we make a change to channels, we just stop them and then we update the channels list and then we watch all of them again. I hope that made some sense. All right, so, and then we just return an observable merging all these watchers, and whenever there's an update to the messages on whatever channel, it will trigger an action. And that action tells you what messages has been updated, or it actually gives all the messages, and it tells you which channel these messages belongs to. So this is actually really nice, I think. I'm trying to compare it to other tools like the Cerebral framework, which I've been working a lot on. And I think actually it, being like the next developer, it will be easier to understand what the heck is going on in the code using Cerebral, because it's so expressive when dealing with this complex stuff. But you would have to write a lot more code. So, and you wouldn't get tools like in between here, we can just delay something, we can filter something, we can do lots of stuff. But it's, for me, it has been quite a few iterations to get to this point, because it's just a different way of thinking. And again, this is like Horizon is an observable API, or an API based on observables. And that, of course, fits very nicely with rxjs. But what if I wanted to work on a completely different API that wasn't based on observables? Would this be a good way? Would it be good to use observables or this kind of architecture? That's a good question, I think. But yeah, so let's just finish this off by looking at what's happening here. So let me just refresh again, and I join a channel. And as we can see, when I submit a message, I make a change because I want to reset the messages text here, or make it empty. And then that triggered an effect, which caused a side effect where I first joined the channel because I handle the message, and this is happening synchronously. Like, a side effect doesn't have to be async, it can be completely synchronous. And that changed the state in the user because we added the channel. And then we triggered side effects again. Because other parts of the system also reacted to joining this channel. For example, the messages. So what happened is that it started listening to messages, and it updated the messages array. Or it triggered a messages action. And then it stored that on the user. And if I leave this now, we can see that I leave the channel and I'm not getting any updates on new messages because I've stopped watching them. And I can join test and something else. And I can write something, and yeah. And the point here is that what I think is important, that if you do this kind of architecture like Elm-like and Redux, you are completely dependent on debugging tools, because it's very hard to understand the flow of the application looking just at the code. You need help when you make changes to the interface and trigger stuff inside your app to understand what the heck is happening. But if you have that, then I think you have a pretty nice architecture, because looking at this, a lot of things can happen. Like you trigger one action which causes a side effect, and that side effect causes another side effect which causes another side effect, and so it kind of moves on. And that is very difficult to create a mental image of. But okay, I've been talking like crazy now. I hope this was to some help and some interest, and you should definitely check out Horizon. And if you want to check out this rxjs app thingy, it's just rxjs app. And yeah, have a nice day.